Hello, good evenings, everyone, and welcome to our food industry webinar today. So this time is the episode season 4 already, and this one is episode 2 for this webinar. And today we have the guest for our exchange staff in here. So today we had the very hot topic about the food processing, and of course everything know that sustainability is very important topic for nowadays in the food industry. And by this currents of this topic, we have the special guest from the associate professor Dr. Hyun from the Inje University will be share the knowledge about this topic with us today. So the topic is today is current status of the future of upcycling food processing. And this one is very important and everyone is talking about the sustainability, and I hope everyone enjoy this one. But before we starting on the webinar, I would like to introductions a little bit about the professor. He is the exchange professor here for 1 month with his student from the Inje University. He graduated for PhD in Department of Food, Pharmaceutical, and Biotechnology in Inje University. Now he is the associate professor, the full professor in Inje University, and his research interesting. It's about the research on food shelf life extension technologies and sterilized process technology research, also with bioconversion technology research, bioavailability research on the natural bioactive substance, and also its analysis, separation, and purification of natural bioactive substance too. So based on his research interesting, I believe that you are in the good hand of this topic. And also today, Dr. Orashon, is not come alone. I have the co-MC. Is a PhD student from our faculty. Mr. Damian will be my co-MC for today. So I know that everyone would like to listen about our topic today already. So please say hello to Professor Lee. Hello. Do you hear me?
Hello,
Hello.
good
Thank you.
afternoon.
Yes, for sharing the knowledge with us. Could you introductions about your topic, and everyone please give the big hand to him. Thank you so much. The floor is yours.
Okay, okay. Oh, just a moment. Sorry. Okay. Good afternoon, everyone. Thank you for joining me today. We are going to explore the current status, future prospects of upcycling in food processing, revolutionary approach that transforms waste into valuable resources. Okay, my name is Hyun, and I'm excited to guide you through this presentation, which highlights how upcycling contributes to sustainability, innovation, and economic growth in the food industry. Okay. Okay, the presentation, the tables of content is as follow. Just 6 to 7 contents. Okay. Sustainable food processing refer to methods that minimize environmental impact while ensure food safety, quality, and nutritional value. It aims to promise resource efficiency, reduce waste, and conserve energy and water. This approach also focuses on minimizing the use of harmful chemicals, promoting recycling and reuse of waste, and ultimately achieving both environmental protection and the provision of health food. Okay. The food system, that figure, needs to generate positive value along three dimensions, economic, social, and environment, three parts. Next, I will now talk about the key principles of sustainability. First, energy efficiency. Energy efficiency focuses on reducing energy consumption during food processing. Right side. This diagram highlights the use of renewable energy sources such as solar panel and wind turbines alongside energy-saving equipment. By optimizing energy use, processors can lower their carbon footprint while reducing operational costs. Second, water conservation. Water conservation is a critical aspect of sustainability. Advanced water recycling systems such as filtration and reuse technologies are represented in the diagram. This side. Okay. These systems reduce water waste, protect freshwater resources, and ensure sustainable production processes. Third, waste management. Effective waste management involves minimizing food waste and redirecting organic byproducts for composting or repurposing. The infographic slide uh, in- okay, showcases composting bins and advanced water reduction technology that prevent landfill accumulation and promote circular economics uh, within food system. Fourth, packaging innovation. Okay, sorry. Okay, packaging innovation focus on reducing the environmental impact. Uh, sorry, envi- environmental impact of packaging materials. Eco-friendly designs such as biodegradable and reusable packaging are highlighted. Fifth, upcycling in food processing. Upcycling transforms food by product and surplus ingredient into a valuable product. This principle is depicted through creatively used methods such as turning food waste into animal feed or fertilizer or edible products. Okay. Okay. Let's start by understanding what upcycling means. Upcycling is a process of adding value to materials that are often considered waste. Especially in food processing, upcycling involves turning by product, spent grains or fruit peels into high value product, sorry, such as energy bars and snacks. This concept aligns with the principles of the circular economy by reducing waste and extending the life cycle of raw materials. Okay. There are two main ways to reuse materials, recycling and upcycling. Recycling takes old materials and breaks them down into new materials that can be used for other products. Upcycling takes old materials and transforms them into something new and better than what they were before. Both recycling and upcycling are important parts of going green and reducing uh, carbon footprint. Right side infographic. The circular economy is a model of production and consumption, which involves sharing, reusing, reusing, repairing, refurbishing, and recycling, extinguishing materials and products as long as possible. Next. Okay. Why is upcycling important? Let's examine some alarming statistics. Globally, about 1.3 billion tons of food waste, uh, food waste contributing to 3.3 gigaton of carbon dioxide emissions, making food waste one of the top contributors to climate change. Additionally, there are two key issues below. We must address first agricultural byproducts like spent grains and soy pulp remain largely underutilized. Second, strict aesthetic standards in food production lead to the rejection of perfectly edible produce, adding to waste. Uh, as you can see in the graph right side, food waste and its environmental impact are rising. Addressing this issue require innovative solutions and upcycling present a powerful opportunity to reduce this waste while creating value. Okay, next slide. Upcycling offers multiple benefits. First, conserve resources such as water, land, and energy, which are heavily consumed in traditional agricultural practice. Utilized by product, we can significantly reduce the strain on these resources. Okay. Second, upcycling supports the circular economy by transforming waste into valuable products, thus creating a closed loop system that reduces environmental impact. Lastly, consumer preferences are shifting toward sustainability. Surveys showed that 80% of consumers uh, properties sustainable product demonstrating a growing market demanded of upcycling goods. Uh, right side, this diagram illustrated the resource saving and environmental benefits achieved through upcycling. Okay, now let's explore some real-world examples. First, Reclaimed is a company in the United States that upcycling spent grains from the brewing process. These grains, typically discarded, are transformed into high protein, high fiber, and so on energy bar. The impact is remarkable. Uh, Regrain, uh, Regrained prevent 2 billion pounds of waste annually, showcasing the potential for upcycling to reduce food waste while creating remarkable nutritious product. Okay. This flowchart illustrates right side. This flowchart illustrates their process from spent grains to energy bar. The flowchart represents the manufacturing process for regrained product in step-by-step manners, uh, all of five steps. First, spent grain collection from breweries. This is the start point of the process. Spent grain, a byproduct of beer brewing, is collected from breweries. These grains are rich in nutrients and are repurposed instead of being discarded. Second, grain drying and milling. After collection, the spent grains are dried and milled to remove the excess moisture and prepare them for further processing. Third, formulation and mixing with other ingredients. The dried and milled grains are combined with other ingredients to create the desired flavor and nutritional profiles. This step involves precise mixing to ensure consistency. Okay, next step, shaping and baking. The formulated mixture is shaped into the desired product forms, such as bars or other snacks, and baked to perfection. This step gives the product its final structure and texture and so on. Finally, packaging and distribution. Once baked, the product are packaged in eco-friendly materials and distributed to retailer or customers. Okay, next, Louvre is another inspiring example. Based in the United Kingdom, this company repurposed surplus materials. Okay, BCF fruits and vegetable into products like ketchup and jams. By doing so, they not only reduce food waste but also encourage ethical consumption. Here are outside. Here are before and after image that showcase their transformation of reject products into premium quality products. This example highlights the social and environmental value of upcycling. Okay. Okay, next, Renewal Mill USA is a sustainable food company dedicated to combating food waste and climate change by upcycling byproduct from manufacturing. Okay, Renewal Mill focuses on soy pulp, also known as okara, which is a byproduct of soy milk production. By turning okara into gluten-free, high-fiber baking mixes, they cater the health conscious consumers and address the growing demand for sustainable food, plant-based products. Okay. Uh, okay. This picture is Okara manufacturing flowchart. Okay. Number one step, collect soy milk byproduct. Okara, a nutrition-rich byproduct of soy milk production is collected from processing facilities. Next, clean and dry okara. The correct okara is cleaned to remove impurities and dried to increase its shelf life and prepare it for further processing. Next processing, mill okara into fine flour. The dried okara is built into a fine flour, creating a versatile, protein-rich ingredient suitable for various food applications. Okay, next 단계. Okay, next step. Package Okara-based flour. The Okara flour is packaged in eco-friendly containers, ensuring it's ready for storage, distribution, and use at uh, living room and so on. Okay, next, Kronkomer in Netherlands. In the Netherlands, Crocomore tackles the issue of aesthetic food waste. They repurpose ugly vegetables that do not meet retail standards into sauce and uh, other materials. Their efforts save thousands of tons of vegetable annually, proving that upcycling can be uh, both economically vis- viable and environmentally impactful. Its downside, its infographic details the impact of their uh, work on reduced vegetable waste. Okay, farm to product pathway. The infographic shows how imperfect vegetables are rejected due to cosmetic imperfection, while overproduction are collected directly from farms. These vegetables are transformed into high quality products like soups and produce. Next, reduced food waste metrics. Visual indicators highlight the significant reduction in vegetable waste. Thousands of tons of vegetables are saved annually, emphasizing the environmental impact of Chroma's works. Next, let's take a look at Kaju snacks. On innovative company based on no 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 based in the United States. CardSnack is a premium uh, example of how upcycling can turn by produce into sustainable and profitable food products. Okay, CAD focuses on upcycling corn products, especially the remnants from corn processing. Okay, these byproducts are typically discarded and still retain substantial nutritional value. Instead of letting these resources go to waste, Kaju repurpose them into environmental friendly corn chips. Okay. Right side figure shows a flow diagram of process, corn byproduct, and processing last to make the corn chip. Okay. Next, we will delve into components and processing methods of byproducts from seafood, meat, grain, and vegetable foods are part of process methods uh, available upcycling section. Seafood processing generates millions of tons of waste annually, including fish skin, bones, and shells. However, these materials are rich in proteins, minerals, and bioactive compounds that can be upcycled into high-value products. Some examples of upcycled seafood products include marine collagen, chitosan, calcium supplements, fish meal, and oils. Okay, marine collagens extracted from fish skin, widely used in beauty products and supplements for its skin and joint health benefits. Chitosan, uh, biodegradable material from shrimp shells annually, with application in uh, wound healing, water filtration, and sustainable packaging materials, and so on. Calcium supplements derived from fish bones, providing a sustainable source of dietary calcium. Okay, fish meal or oils have a high protein product used in animal feed and aquaculture. Example, for instance, marine collagen has seen tremendous demand in the wellness industry due to its anti-aging properties, creating a multi-billion dollar market opportunities now. Okay, upcycling seafood by products involves several steps below. Uh, First step, collection. Collections are gathering by product from seafood processing plants. Second, cleaning and drying, ensuring the raw materials are safe and ready for the use. Okay, next step, processing. Advanced technology like enzymatic hydrolysis extract marine collagen, while heating from shrimp shells is converted into ketosan through deacetylation. Uh, Next, preservation. Pre-drying retains nutrients and extends shelf life. Okay, next, the meat industry also generates substantial byproduct, including bones, hides, fats, and blood. While often discarded, these materials hold significant potential of cycling into valuable products. Okay, some notable products include gelatin and collagen, biofuel and biogas, fertilizers, pet food ingredients. Okay, the meat upcycling uh, process includes below. First collection step, gathering byproduct by slaughterhouse or meat plants, and preparation, cleaning and sorting raw materials, and processing step. Okay, processing step technology like thermal hydrolysis extract collagen, while anaerobic digestion converts fat into biofuel, and packaging step. Finished product like fertilizers or pet food are packaged for distribution. Okay, next, grain husk fields and surplus vegetables are often wasted despite their nutritional value. Upcycling these materials can create high demand products uh, like based proteins, biofertilizer, and vegetable powders, while significantly reducing organic waste. Some key examples include for vegetable powders, plant-based protein, biofertilizer, animal feed. Okay, the process involved below. Collection step, surplus or byproduct from food processing facilities. Next step, preparation and fermentation step. Microbial systems enhance nutritional value and break down anti-nutrients. Next processing step, commonly spray drying for powder or fertilizer for animal feed. Okay, now let's explore the topic of technologies and enable upcycling. First, enzymatic hydrolysis. Okay, enzymatic hydrolysis is a technology used uh, bioactive compounds like collagen and proteins from byproducts. Okay, enzymes break down proteins into small peptide or amino acids. Application part, marine, collagen supplements, and gelatin for food and cosmetics. This process is efficient, retains nutrients, and produces high quality outputs. Example, fish skin can be processed using enzymatic hydrolysis to extract collagen, which is then freeze dried for use in dietary supplements. Okay, here's a flow diagram showing how enzymatic hydrolysis extracts collagen from fish skin. Okay, next, fermentation enhanced nutritional value, preserves materials, and creates new functional properties. Microbial is applied to the grain, vegetable, or organic waste. Application parts, biofertilized plant-based proteins and probiotics, foods, and so on. This technique uh, reduced waste decomposition emissions and enhance digestibility. Okay, example, surplus vegetable can be fermented into probiotics rich foods like Korea food, kimchi or freezable for biofertilizer production. Okay. Downside, this slide shows fermentation tanks left side and example of fermented product right side. Okay, next, spray drying convert liquid or slurry materials such as vegetable purees into shelf-stable powders. Okay, uh, the liquid feed atomized into fine drop and dried in a hot air chamber. Vegetable powders for soup and supplements, food powder for snacks. Okay. Spray drying retains nutrients and flavors while make products lightweight and easy to store. Okay. One example. Carrot juice waste can be spray dried into a powder for use in health supplements. Okay. Downside, here's a diagram showing the spray drying process and examples of finished powders. Okay, next, freeze drying preserves sensitive nutrients and flavors by removing moisture through sublimitation. Limation. Uh, Food is frozen and subjected to process, low process environment where water is removed as vapor. Marine collagen supplements dried fruit and vegetable application. Okay, maintains nutrient profiles, extended shelf life, and produces light weight product. Okay, example, freeze-dried strawberry retain their flavor and nutritional content, making them popular in snack. Okay, downside figure. Okay, this comparison showing the difference between fresh and freeze-dried product. Okay, next, high pressure processing or HPP is a non-summer non-summer food preservation method that extends shelf life and enhance the food safety while maintaining natural uh, nutrients. Okay. Uh, The primary goals of HPP is to preserve food and extend its shelf life no, no, without the need for chemical preservative and or additives. Okay, process part. Foods are packed in water-resistant containers and placed in a high-pressure chamber filled with water. Pressure as high as 6,000 bars is applied on no, no, no. Uniformly inactivating pathogens, supplies microorganisms, and enzymes. Okay, application part, ready to eat food, fresh juice, purees, and baked food. Okay, advantage part, preserves heat sensitivity nutrients, enhance food safety by eliminating pathogens like Listeria and E. coli. Okay, example, fresh orange juice processed with HPP retains its vibrant color and vitamin C content while eliminating harmful microorganisms, making it safer for consumer. Okay, downside. Here's an image showing an HPP system and example of foods. Okay, next, thermal hydrolysis is a powerful technology that accelerates the breakdown of tough organic materials into simpler, available components. Okay, this process is particularly effective for converting uh, food byproducts like bones or husks into high demanded products such as collagen and biofuels. Uh, Next sentence. The primary purpose of thermal process is to transform complex organic materials into forms that are easier to process and utilize. By using heat and pressure, uh, it allows us to efficiently extract nutrients and energy from food waste. Okay. Uh, next, okay, downside, uh, application part. This technology has a range of applications, including uh, collagen extraction, biofuel production, and so on. Okay. Last example. For instance, chicken or beef burned from meat processing plants can be subjected to thermal hydrolysis to produce collagen powders, which is then used in supplements and cosmetics. Okay, downside. On this slide, you can see a diagram illustrating the thermal hydrolysis process highlighting its ability to extract collagen and creative biofuels efficiently. Okay, next, let's now discuss advanced filtration technology, which play a critical role in upcycling food waste. These systems are designed to purify and separate variable components from food byproducts, enable precise recovery of nutrients and functional compounds. Okay, first purpose. Advanced filtration systems aim to isolate and purify proteins, fats, and minerals from food waste. These components are then repurposed for use in supplements, animal feed, and so on. Okay, process step. Filtration use membranes or nanofiltration techniques to separate molecular based on size and structure. The result is a high quality product with minimal contamination. The last example, uh, one excellent application is extracting high quality, sorry, fish oil from seafood processing waste using nanofiltration, which retains omega-3 fatty acids for supplements. Okay, downside. Here's a diagram showing how filtration systems isolate key nutrients efficiently. Okay, next, the potential of upcycling food is immense. Let's start with each environmental benefits. Research shows that incorporating upcycled ingredients into food systems significantly reduce the food waste and greenhouse gas emissions. Nutritional studies reveal that byproducts such as okara or spent grain retain essential nutrients like protein and fiber, making them ideal for creating nutrient-rich food products. Economically, upcycling food fits seamlessly into the concept of circular economics, transforming waste into available resources. Okay, let's say, for example, a product derived from fruit pulp and vegetable peels are entering the market as premium sustainable options. Okay, next, innovation is at the heart of upcycling food research. Let's discuss some cutting edge advancements. Okay. First, new processing methods such as advanced drying, fermentation, and milling technologies are transforming byproduct into stable, high-quality ingredients. For instance, spent grain from brewery is now being converted into facile baking floors. Collaboration between disciplines like food science and engineering has paved the way to applications beyond food, uh, include, including biodegradable packaging and bioplastics. One notable case study involves a partnership that optimized spent grains uh, stability in snacks and health supplements. As researchers, our role is to push these innovations forward while ensuring they are scalable for industrial use. This is very important. Okay, outside this picture, this image showcase some of the lab equipment used to analyze upcycled ingredients. Okay, next, while the potential is best, upcycled food processing comes with significant challenges. One major barrier is funding. Okay, funding is very important. Sustainable innovation often competes conventional research area, making it difficult to secure resources. Another issue is the lack of standardization in analyzing nutrient composition and ensuring consistency in the quality of byproduct sources from different industries. Okay. Public perception also remains a hurdle. Many consumers still view byproduct-based food with skepticism. Lastly, variability in byproduct supply chain can create logistical challenges. For example, seasonal uh, fluctuation in fruit and vegetable production affect the available of upcycling raw materials. Okay, this chart highlights these challenges while suggesting research-driven strategies to address them, uh, such as public awareness campaigns and supply chain optimization. Okay, researchers are key to driving the upcycled food movement forward by publishing findings. We provide critical knowledge that helps industries adopt upcycling methods. Development is another important area. Scientific evidence can shape regulation that encourage food waste reduction and incentivize upcycling practices. Innovation is at the core of our approach as we continuously identify novel application for byproducts. such as incorporating upcycled into mainstream baked goods or creating functional food ingredients. Last, collaboration is essential too. Partnering with industries ensure our innovations can be scaled and implemented effect- effectively. Uh, as research, as some researchers, we have the opportunity to not just study this field, but actively contribute uh, to a more sustainable food system. Okay, finally, let's take a look at the future of upcycled food processing. Emerging technologies like AI-driven techniques and control systems automation are uh, poised to enhance efficiency, ensuring consistent quality and safety in upcycled products. One, global scale expanding production capabilities will allow us to meet international food waste reduction goals, particularly in regions where food waste is a significant challenge. Consumer integration will be a critical focus by educating the public on the benefits of upcycled foods and creating accessible, appealing products, we can drive mainstream adoption. Additionally, policy influence will play a pivotal role in fostering governmental support for upcycling initiatives, such as tax incentives or uh, grants for companies engaging in food waste reduction. This vision for upcycled food is not only achievable but necessary as we work toward a more sustainable and circular food economy. Okay, next secret part. I briefly introduce two of my studies for focus on upcycling materials, demonstrating how byproduct can be transformed into variable resources. Okay, the first study I will present is titled Enhanced GABA Production Using Lactic Acid Bacteria. This study utilized rice bran, a byproduct of rice processing as the upcycling material. Rice bran is nutritionally rich, containing functional compounds such as tocopherol, gamma orygenol, ferulic acid, and so on. In Korea, approximately, approximately for 40 billion tons of rice bran are produced annually. However, only 5% is utilized to produce rice bran oil, while the majority is relocated to low value uses such as animal feed and so on. Next, GABA introduction. GABA, the focus of our study is non-protein amino acid synthesized via the alpha decarboxylation of glutamic acid. It is widely recognized as a functional component that supports brain health, contributing to improved cognitive function and stress regulation. Okay, the mechanism for GABA production is illustrated in this figure. GABA is produced through the decarboxylation of glutamate by glutamate decarboxylase. This reaction is facilitated by the compact pyridoxal phosphate, just PLP. Okay, next, the primary objects of this study are threefold. First, to isolate and identify GABA producing microorganisms from traditional fermented foods in Korea and select the medium condition and okay, effective strains selection. And second, to determine the optimal fermentation conditions for maximizing GABA production. Last, to access the pad batch fermentation method as a means of enhancing GABA production, efficiency, and performance. Next, as outlined, the research method comprises several key steps. Setting pre-treatment conditions for rice grain and ensure microbiome stability, isolating and identifying microorganisms capable of producing GABA, analyzing the composition of the rice grain medium, and quantifying GABA and glutamic acid levels in the fermented product. Okay, next, to ensure microbial stability in rice bran, pre-treatment conditions were established based on the D value. Okay, rice bran medium was prepared by incorporating 10% rice bran, and the D value was determined at 100 Celsius and 121 Celsius. Sterilization was performed at 100 Celsius for 7.56 minutes, achieving conditions suitable for a commercial application. Okay, next, we used an API key to access the carbohydrate reactivity of LW. Okay, LW strain isolated from water kimchi in Korea. The result indicated that LW exhibited 99% similar Lactobacillus plantarum strains. Next, when the strains LK isolated from cabbage kimchi was tested for carbohydrate reactivity using API kit, the result revealed that it exhibited characteristic 99%, 99.7% similar to Lactococcus lactis. Okay, furthermore, detailed and accurate identification of the isolated strain 16th RNA analysis was conducted. The result confirms that the LW strain belong belonged to the Lactobacillus genus, uh, aligning with the findings obtained from the API kit. The placement of the LW strain in the homology tree further validated its classification within Lactobacillus group, ensuring consistency across both biochemical and molecular identification methods. Okay, the result of the 16th RNA analysis for the isolated strain LK revealed a discrepancy with the API kit. While the API kit initially indicated a 99.7 similarity lactococcus lactis, the 60th RNA analysis provided more precise identification, classifying the strain as Pediococcus penta success. Okay, based on the evaluation of key factors such as temperature, starting speed, such as agitation, and fermentation duration, the optimal conditions for maximizing GABA uh, production were determined to be uh, 35 Celsius, 50 RPM, and 18 hours of fermentation. Under these conditions, the LW strain demonstrated the highest fermentation efficiency. Furthermore, experiments investigating the composition of rice grain medium revealed that supplementing the medium with 3% glutamic acid significantly enhanced GABA production, resulting in the highest yield. Okay, next, the study on GABA production using a pad beach fermentation method was designed based on the optimized conditions identified in the previous experiments. Initially, the primary medium was prepared by adding 1% glutamic acid to 1000 milliliters of rice bran medium. Subsequently, 200 milliliters of rice bran medium supplemented with 3% glutamic acid was added at 5-day intervals, totaling three additions. The fermentation process was carried out over a period of 20 days to evaluate the effectiveness of the pet-based approach in enhancing carbon production. Okay, the result of analyzing the change in glutamic acid and GABA contents at 5-day intervals using thin layer chromatography, just TLC, are shown in the plot. Okay, clearly demonstrate that the GABA spot intensifies and becomes progressively darker with each addition of the rice bran medium, and as the fermentation time advances. This indicates a consistent increase in GABA production of the fermentation period. Next, high-performance liquid chromatography HPLC analysis was used to monitor the changes in the content of GABA and glutamic acid throughout the fermentation period. The result confirmed that the glutamic acid added to the medium was actively converted into GABA by the LW strain as the fermentation progressed. Building on this finding, we are currently conducting a follow study to optimize the conditions for PET production on industrial scale use on industrial fermenter plant. Okay, next, we conducted a study focusing on the physiological activity of fermented oyster produced using Lactobacillus brevis. Oysters are widely cultivated in Europe and Asia. It's a highly valued aquatic food resources. Their edible portions are rich in essential vitamins, minerals, and high-quality proteins, making them excellent food ingredients. Previous research has highlighted the physiological benefits of oysters, including antioxidant, antimicrobial activity, and anti-inflammatory activity, and so on. However, in Korea, approximately 30% of oysters lose their markability during processing, resulting in significant devaluation. This study aimed to address this issue by exploring the potential of oyster fermentation to enhance their valuable and functional properties. Okay. During the fermentation process using oyster extract, we observed a significant increase in amino acid, um, including taurine, glutamic acid, and glycine, and so on. In animal experiments conducted with SHR, spontaneously hypertensive rats, uh, we noted an increase in low molecular weight peptide, just di-1,3-peptide, which demonstrated a blood pressure reducing effect by inhibiting angiotensin converting enzyme, thereby mitigation hypertension. Furthermore, the fermented oyster showed promising effects in preventing bone loss caused by oveotomy as it suppressed osteoclast production. These findings highlight the potential of fermented oyster in contributing to cardiovascular and bone health. The progress of this research is illustrated in the below chart. We are currently collaborating with a joint research team to finalize a paper and patent based on these physiological activity research. Detailed finding will be shared in the future when the study is published and patented. Okay. Okay. This concludes my presentation. Thank you for your attention and interest in our study. I would be happy to address any question you may have. Thank you very much.
Okay, thank you very much, Professor. This is Damien here. I'm taking over the question and answer section from Ajan Urachon. Um, Thank you. This has been very enlightening. The introduction, particularly about upscale. Usually we hear about recycling, right? So it's about mostly the product going back to its original source. But this upscale recycling is it's a very enlightening for me in particular, and it's very interesting. There are a number of questions, but I think I will start first here. So, what in your research, what do you think is the issue with the perception about products that are produced from upcycling? I think if people hear about the food they eat coming from, for example, byproducts, or usually people refer to them as waste. They feel like maybe, oh, this product is inferior or like not the same quality like the regular products. Is this is this something that is generally perceived by most consumers, or is it something that is not really a problem for products that are produced by upcycling uh, processing?
Okay, okay, yes. I believe upcycling process significantly contributes to a sustainable food industry. Okay, by transforming food product into high value product, reduce waste, lower environmental impact, and promote circular economy. Uh, okay, finally, it provides opportunity to create nutrients and functional food, making the food system more efficient and sustainable. Okay. In the future, I plan to focus my research on two key areas of upcycled food processing. First, I think, to develop techniques for enhancing the beneficial components in byproducts through fermentation. This includes increasing to bioavailable rate and concentration of functional components to maximize their nutritional and health benefits. Second, I intend to explore methods for diversifying the physical properties of byproducts to create versatile food processing materials by improving their texture, stability, and usability. These byproducts can be incorporated into a wider range of processes, food, um, expanding their application and value. Okay.
Okay.
Lastly, I think in research on upcycling materials, fermented or processed substances are often composed of complex mixture. So, unfortunately, uh, while make while make compounds may be known, the overall efficacy should be validated through studies such as cell and animal experiments.
Okay. All right. Thank you. Thank you very much for the answer. So there are a number of questions also from the other participants. So I will go through them one by one. So the first question is that so you mentioned high pressure processing in as one of the techniques in in food sustainability. And so one of the participants was asking whether or not there's any disadvantage from using the high pressure processing in food sustainability.
Okay. Uh, ago, 10 years ago, 10 years ago, I studied HHP treatment for various food materials. Uh, HHP treatment occurred very useful result, such as bioactive compound content increased and uh, food ingredient content stability and so on. But HPP system, uh, the machine facility and accessory is very expensive uh, because high pressure high pressure occurred break down uh, machine party. I think 5 years, after 5 years, instrument industry improvement and new machine materials developed HHP. Uh, HHP research and industrial adoption is increased, I think.
Oh, okay. All right. Then that's good. Thank you very much for the answer. The next question, so with the foods that are produced, I think you gave a number of examples of some companies that are using these raw materials that are rejected and using the process of upcycling, sorry, to improve these ingredients. And someone is asking if upcycling, it affects the taste and quality of the final product that is produced.
Okay. Okay. Uh, I will tell you company trends. First, leading companies in upcycled food processing are focusing on innovation and sustainability. Uh, they are leveraging advanced technology like fermentation, drying, and extraction to transforming byproduct into high-value products such as functional food, snacks, and beverage. I think these companies are also prioritize transparency, eco-friendly, okay, consumer education to build trust and awareness. Okay, and upcycling food processing. Various research focuses on utilizing byproducts from various industries to create high-value products. Common materials include rice bran, um, which is rich uh, or nutrients components. And I think in Thailand, there is significant potential in materials like coconut husk and marine shells, which can be used for functional food product nutrition product or beverage and shrimp shells, which are rich in chitin and can be processed into chitosan for nutritional or biomedical applications. Lastly, by exploring these materials cases cannot only reduce waste but also developing innovative and sustainable solutions for the food industry. I guess.
Okay. All right, then. Thank you very much. I will move on to the next question, and it's about AI. So artificial intelligence is growing in every industry in the world, every part of the world. We have artificial intelligence. And this participant wants to know if you know of AI being used or in a way by which AI is being used in food upcycling.
Okay. Okay. Traditional food research is research paper, search, and schedule makes, uh, and then long-term experiments and result and discussion part. But AI, such as ChatGPT, uh, is uh, adopting make the stimulation uh, various food processing byproduct, nutrient, DB, and so AI adopting is occurred uh, research uh, area is innovation. I think, yeah.
Yeah. So so AI is contributing a lot to our lives and also improving. So I think that probably this is also, as part of the technologies that are being developed. Yes, AI may be a part of it as well. So the next question says that there are many technologies for upcycling, which I think you mentioned a few: fermentation, high pressure process, and so on. So this participant wants to know how we should choose the most appropriate technology for upcycling.
Okay, uh, okay. Mm, okay, I think in upcycling food processing, the most critical factors is ensuring the microbiological safety of the materials. It's very, very important. This is essential for making byproducts that are less backward and difficult to use, viable for consumption. Therefore, it's necessary to apply methods that make these materials safe for use. Uh, the cause adopting various treatments such as uh, irradiation and ozone treatment and milling, various milling system, uh, such as nano milling system and so on, I guess.
Okay, thank you very much. If there are any more questions, any participants have any questions, you can type it in, or if you would like to ask the question yourself, you can do that. You can just unmute and then you can ask your question. Does anyone have any more questions?
Uh,
Anyone?
yeah, just a moment.
Okay, so then I guess these are all the
Uh,
questions for you, Professor Sangjun Lee. Thank you very much for the presentation.
okay, thank you very much.
We really enjoyed it. But before we go, we would like to take a picture, a quick picture. Prof, if you can stop sharing the screen. We will just take a group picture. Everyone put up, open your camera. And please smile. We will take pictures to commemorate the day. All participants, please open your cameras. We're going to take pictures. We want to see your beautiful faces and handsome faces while we take the pictures. Okay, still waiting. Okay, there you are. That's good. That's good. That's very good. All right, this is great. So, we're going to take the pictures. There we go. There we go. I'm still waiting on a few others. Everyone is looking very beautiful today, and the guy is too handsome. That's good. That's very good. I'm still waiting on a few more. I'm still waiting on a few more, and then I will start taking the pictures. Please smile. Smile. Very good. Still waiting on a few more. All right. Don't worry if you're not looking very good. It's fine. Yeah, that's good. That's good. There we go. All right. All right. That's very good. That's very good. Okay. All right. I think there are some who still don't want their faces to show, so we'll still go ahead and take the pictures. Okay. All right. Okay. I think there's more. Okay. Hold on. One more. All right. Okay. Okay. I think there's
All right.
more.
Thank you very
Hold on.
much.
Hold on. One more. All right. Okay. Okay. I think there's
All right.
more.
Thank you very
Hold on.
much.
Hold on. One more. All
Thank you
right.
very much.
Okay. Sorry, so I think yeah. Okay. Sorry about that. So everyone is going to get a certificate from the program. Sorry, so I think yeah. Okay. Sorry about that. So everyone is going to get a certificate from the program. Sorry, so I think yeah. Okay. Sorry about that. So everyone is going to get a certificate from the program. Sorry, so I think yeah. Okay.
Okay.
Okay, so right on your screen is the certificate. You can scan for the certificate for this webinar. So you can, for those who can, you can take a screenshot and then you can upload it and follow the instructions so you can get your certificate. Sorry about the feedback earlier. I think we had a few challenges over there. Okay. So for those interested in certificates, you can, and there's also the link has been provided on the message board. Just go to the messages and then click the form and then fill in your name and all the other details, and your certificate will be sent to you. Okay. All right. So if you're on right now, you can go to the chat section. There is a link over there that has the forms. So you click on the form and then you can fill in the information and get your certificate. Thank you very much, everyone, for joining. Ejan Orachon, please, are you there? Would you like to conclude? Hello, Ajan Orachon. Okay, so then I will conclude on her behalf. So on behalf of the faculty, the dean, members of the staff, and everyone who was part of organizing the webinar, and to you all participants, we'd like to say a big thank you to our professor for this wonderful presentation. And we hope that all of you will take part in our next session or next event of webinar. We do this over a period of time, and it's very interesting. There are some topics that are actually very interesting for students to participate in. So I would like for you to update yourselves on events in the faculty, and then you'll be able to get some of this information and join us. So until next time, it's bye-bye.